Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials or any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
What is the definition of image I said? Anyone remember? We discussed images yesterday many times. So anyone has that memory?
Class ISO.
No. ISO is of course not a definition. It's a. I'm talking the Docker image. That is I said because I wanted to correlate the things with you. What is the definition of image?
It contains the file system and what else? The app file storage.
Definitely plus.
Yeah.
So again, I think if you forgot, please remember, because if you forget that, it will be very difficult to set up images. Okay. So here you see
Definition.
components of Docker, and out of which I said, what is a Docker image? So I said Docker image is nothing but a combination of root file system plus app file system plus user file system, and file system which I have shown you that image. Do you remember that?
Yes. Yes.
Yeah. So this is a combination of file system, guys. File system. Okay. Different kind of file system. Only in the image you won't find a boot file system, which is basically kernel. That means in a container you won't find this. I also mentioned here. Look at this. The moment you run image, Docker image, one container is created which you have experienced, and with all this. And the mount which it get, one mount each container, whatever it gets, it from the image itself. Okay, hope you remember. Now from one image you can create a multiple container also. I said this. Now let's look at this here. I think these all are commands. So now, did you understand that what is the image? Do you remember that what is the image now?
Yes.
Okay, so now let's deep dive into that. So actually when we look at the image, okay, so image, when you look at the image, it has a multiple layer. Yes, we call it layer, but these layers is file system. Yeah, look at this here. A Docker image is made up of the file system layered over each other. Yes, it's a image. It's not a one file actually. It is a file system. Yes, remember, file systems layered over each other, and that is the reason we call it layer 0, layer 1, layer 2. In this image you have a 3 layers. Layer 0 is the bottom one, layer 1, and then followed by layer 2, and this is made up of the one image. So in this you have image has a multiple file system, and we call it layer. Look at this, all these 3 layers coming together and forming one image. Now interesting thing is, you can create how many images from these 3 layers? 3 images you can create. From the layer 0 you can create one image, from layer 1 you can create one image, and layer 2 you can also create one image. But remember here, when you get layer 0, the image, you will see the files inside that container only which is in the layer 0. But if you see the image 1, which is the middle one, if you create a container from the image 1, you see the files of layer 0 plus layer 1. Now, if you create a container from the image 2, you see the files inside a container which includes layer 0 plus 1 plus 2. Are you getting me what I'm trying to say?
Yes.
So guys, that is the reason when you pull the any images like a Jenkins, Ubuntu, CentOS, Fedora, Debian, or whatever the image you pull, they say keep pulling because of multiple pull, checksum pull. Why? Because these are layers actually. Those layers is a separate entity and this is being pulled together, they form one image. So image is just a human naming convention to grouping the layers. Yes, image is not a file actually. Image is a way to group the layers. You see that in this image. You can create as many images, you have to group it. So whether in an image you have a group of 4 layers or 50 layers or 1 layers, it's an image. And each image has a parent and child relationship. That means for the layer 1, the parent is 0. For layer 2, the parent is 1. So that means whenever you call the child, all the parent will be followed by automatically. Is that making some sense here?
Yes.
Okay, so now you see here because each layer is nothing but the file system, the file system will have a different changes. What changes? So you may have that here you have 3 layers. So see here in this layer 0, which is a base image, you may have a root file system. Now what is a root file system? We have spent good amount of time. So understand that when I say root file system, it is not a boot file system, it's not a kernel, only the skeleton of that operating system, which you can see it. So when you log into any operating system, you see the skeleton that is called root file system. That any file system which is getting created from the root and whatever you can see it is being called as a root file system, because boot file system you cannot see it. Make sense, guys?
Yep.
Yeah.
So this is the root file system, and on top of that, what you have? You installed Nginx. And top of that, what you installed? You updated the base operating system Ubuntu. This is something like a 3 layers: layer 1, layer 0, layer 1, layer 2. Different changes. So in the layer 1, you only find the Nginx. Layer 2, you only find the updates of the Ubuntu root file system, and the base image, you only find the root file system of Ubuntu operating system. So understand the conceptually. Now,
So when we created the container out of Ubuntu, does it mean that it just had the root file system?
no. Yeah, that's correct. That's correct. Yeah. If you create a container from the base image, the layer 0, the one which is the bottom one, then you will see only root file system in the container.
Okay, so if we create from Nginx, then we see both
Both,
root file
both,
system as well as okay.
both. Yeah. You got it. Make sense? Yeah. So guys, multiple layers forming together, creating one image, and that image is shared with the container. Yeah, that is important. The single image shared by multiple containers. So yes, you cannot remove images because it's been shared by the containers. That's important. You cannot do that. So from one image, you can create as many containers you want. 20, 30, 40, 50, whatever it is. Now you see that.
So just a question is that this from the containers are actually mounting this particular files and using it, or it is a copy of it is making it?
No. They will. What is happening, because it's a 3 file system, right? They have
Yep.
to merge it together. I'll talk about it. That.
Okay.
But,
Okay.
just because you ask 2 questions, let me not die. Let me
Sure.
not question die. Let sorry.
Sure.
The question not die. So here's like this. So these 3 layers will get merged together, become one layer, and get mounted to the container. That's the reason when you create a container and then you do the in the host machine df-kh, it says merged. Do you remember merged? Anyone?
Yep.
Yeah. So that's like I'll come back to that. So here, this 3 layers is powering the containers. Now, guys, each layer you have a unique identification that is managed by SHA-256. Now, let me tell you here it's like a UUID is a 40 character SHA value. Okay, SHA section. Now this is universally unique. Yes, that's true. It is universally unique. So here you have each ID. That's the reason you must be seeing when you pull that, they'll be saying pulling XYZ one ABCD 1 2 3 4 something like that. You will see the random number. Okay, so that's a universally unique ID which you are pulling basically each layer. So each layer is identified by UUID, but it's not human friendly, right? UUID is like you cannot you cannot I mean, if you ask me, okay, which image you want me to, which till up to the what layer you want me to use it, it's very difficult to tell you the UUID. So what we have got it, image. Image is a name-friendly name for us. Okay, so for the human, so we can use that a name instead of ID. Now, guys, this important. This uh, this is important rule. You have to hard code in your mind, because when you create a container from the image, all the layers, okay, all the layers get merged together. Yes, that's true. All the layers get merged together. So when you merge the layer, you might be having conflict also. Now if you're not able to understand, let me create a scenarios for it. See here, ms paint, and here this is a one layer, this is a one layer, and this is another layer. Okay, now this is the 0, this is the 1. Okay, now what happens here in the opt directory /opt, there is one file which is called raj.txt. Okay, and in this also there is a opt directory, and here in this also there is one file which is called raj.txt. Same file. I am not able to draw properly, but please understand that the content of this file, I love India, and here the content of this file is I love DevOps. Okay, I love DevOps. So now this is the conflict, right? Here in this file system, this layer, you have a same file. Now the containers will show which content. That's a confusion. That's a conflict statement. Are you getting my points here now? So if you create a container, these containers will be merged together and power the container, mount into the container. This is the mount. So now inside a container, you will see this content or this content. Did you understand this problem?
Yep.
Yes.
Yeah. So if you have understood this problem, solution is very straightforward. Please read the first line. So here we are saying higher layer always win when there is a conflict in layers. So in this case, in the container, what you will see? Any idea what is the content of the raj.txt?
I love India.
That's correct. So there is no, it's not a git like we will merge together if there is a conflict. We'll see, we'll sit together and merge. No, it's a file system. There is a rule. Those who come late will be shown first. Simple. Right? This is what you do, right? Yesterday you modify the same file. Then day for yesterday you modify the same file. Today also you modify the same file. So what do you want to see? Today you want to see the today's file or yesterday file? No, you want to see today's file, because it's an environment for computing. It's not a versioning code, versioning system for the source code. That is a Git. By the way, let me tell you here, Git and Docker is from the same parent. Git is powered by SHA-1 algorithm. Docker is powered by SHA-256 algorithm. So both works on the almost same concept. Getting my points, guys? Getting my points, guys?
Yes.
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 Okay. Now the question you must be having in your mind: who is doing merging? Who's doing layering, and how this merging is happening? Who is doing it? So basically all this work is being done by union mount algorithm. Yes. So there's an algorithm which is there in your operating system Linux also and Windows also. So image layering is accomplished through union mount. So what exactly they will do? Please read the third statement only. I will allow you to read it. Okay, so this is something you know that, right? So what happens? Union mount allows you to mount multiple file system. The file system which it can be here in this discussion we are using 3, but it can be 30 also on top of each other. But during that they combine all of the layers in the single view and mount to the container, and which for which the container started feeling like operating system. Because to run any application, I said very clearly, you need a 4 component. One is a network, PMAP, MNT, and one is users. So that for all of this it gets it. So it started feeling as if it's like a complete environment of the application or a single regular everyday file system. Okay, so who's doing all this magic? Union mount. Okay, now interesting thing is all layers are read only except top layer. That is a very good statement. So guys, what happens? All layers are read only. That means the whatever the image you had, let's say image you have a 4 layer, so all are read only except the top layer, and top layer is your container actually. Yeah, what happens? Top layer is your container. So what happens when you create a container? There is a one empty layer get created, and that is your container. That is your container. Look at this image here. You see here 3 images. Boot file system is a part of the host. You have a root file system Ubuntu, layer 2 nginx updates, and those are locked one that you cannot modify. But what happens during the creating of the container? You get one writable layers, and that is where all the changes happens. So anything which modified, it happens in this writable layers, and that's your container. So for this you need to understand boot file system little bit, root file system little bit, you need to understand union amount little bit, and all this stuff. And then this is the last anatomy of the image.
I have a question here. Let's assume in the below layer, there is a directory called /opt, and there's a file called A. And in the higher layer, in the same directory /opt, there is a file called B. So will the container will be able to see both A and B in /opt?
Yes, yes, correct, correct. There's no conflict, no.
Yeah, but same directory is there, right? So that should be fine.
Yeah, yeah, no problem. Same directory. File should not be file system. No, it's a file system.
Oh, okay, okay.
Is this what we call as user space, the writable layer, or
no?
that's a
User
different?
space is a created. It's like a kind of, you see, unseen firewall, something like that. You cannot see it, but still you can experience this. User space is like that.
Okay.
Okay, this is the
So
mount.
when we created the container yesterday, so we could see many of the directories and all those things. So in that also, like many were read-only. Is it? I mean, we didn't try much, but among the directory that were listed, so many were read-only. Is it?
Yeah. So I'll do one thing. I will go through my notepad, because this is the images, this is the official images, and this is the official explanation. But let me try to explain in my ways. So probably that will avoid your confusion. Okay. So let me go to the notes here. Okay, guys, look at my screen here. So the first statement, let's make it like this. First statement: image has multiple file system. Now you understand that, right? File systems. Whereas first file system, fs, I'm using the shortcut fs for, please understand this. So image has a multiple file systems s, where the first file system is always, what is that? What is that?
Root package.
Root file system, yes. Now on top of it, other application file system. Okay, what happens? Union mount, understand that, union mount merge all these layers and create, understand that, merge all these layers and create one layer. This is writable layer, read and write. The rule is, in case of conflict, top layer always win. Now writable layer is divided into, for time being I'm telling you two parts only, because actually it's three part, but I don't want to confuse you the too many things, actually don't need right now. So writable layer divided into the writable layer is divided into two part. One is diff and one is I think work. See, I have a very bad memory. I'll see and I'll correct it if it's like this. Diff and work. Sorry, merged. Also, third one merged. Got it. So diff merged. Okay, merged. What happens? This merged layer is a merge of all layer. Merge of all layer of image. Diff directory contains only changed, when I say changed, added, deleted on top of image merged layer. Do you remember the diff command? Anyone remember?
Yes.
That query, this one only. Okay, that query. Okay, so this is the things, work layer. I'll not confuse you the too many things. So let me see that. So yeah, merge layer, type this. Okay, understand this. Merged get here, merged get deleted when you stop a container. Created when you start a container, or start or run. Start and run a container. Okay, this is something what we have here. This layer is a delta change done in the container. This need to be created read only layer with another image. Okay, so something like this is the image. Now I think if I show you the demo, it will be more clear for you. Can I go for the demo?
I understood everything, Rajesh, except for the last point, that if this needs to be created read-only layer with another image.
So basically, see here, if you look at this image, each and every layer has a delta only, not everything. So now, if you change this image, where's that? If you change this image and you have a delta in this, so you don't want merge layer, you want only the delta to be created, because anyways you create new image and then you create a new container, so all the merges will happen by union mounts again, right? So avoid the duplicacy. Same data, it should not be in the two place. No problem. I'll show you the demo now. You will understand this.
Sure.
Okay. Okay. So now I'm doing something here. This is my machine and restart it. CentOS. Okay. So guys, I will clean up, because why I want to clean up? Because I want to have a very fresh demo and from scratch. Okay. So I want to clean up. Now the question is, I need to stop. I need to remove, and then I need to remove images also, by the way. Okay. Yes. Nginx, Ubuntu, Hello World, Jenkins. I deleted everything, clean environment. You see here, guys, there's no images right now. Now the question is where the image is being stored. So I will see the Docker info and I will get to know, I will read this storage driver overlay 2. So here it can be overlay 2, it can be ops, it can be device mapper, it can be overlay also. Right now overlay 2. So that is where the layers will be stored, image layers will be stored. So go to the var lib docker, and here there is a overlay 2. If it is a different storage driver, the directory will be different. So that's the reason I'm saying no matter which operating system, which storage driver you are having, you can try. Now if you go inside this, okay, here let me check the size of it. It's a 0 bytes, that means nothing is there. So now can I pull this image? Which image? So I'll play with a simple image, few layers, because Jenkins has a too many layers. So I will play with the Ubuntu, which you know very well. So I'm pulling this, and now you see here pulling 1, 2, 3, 4. That means I believe there is a 4 layers of it, because I downloaded 4 pull. You see here. So did we get the 4 layer or not? Look at this. 1, 2, 3, 4. So now this is proven, right? Each layer, each image is having multiple layer. Correct now? This is a multiple layer. But you want to see also root file system. So where is the root file system? So I'll play a trick here. Du-sh max depth is equal to 1. Which is the highest size, highest in size? 76 MB. So I will go inside that. It's a base image, and in this I want to show you the root file system. Have you seen this, guys, somewhere?
OS file system.
Yeah, so it is a root file system. So this is a layer 0. Okay, this is a layer 0, and any other layer will have a few files. Some files I don't know. You have to check that. So if you go in this, here you have what? Diff, and you, oh, I think I did same layer together, 3737. So I have to go back, same thing. So this time 47.
To get our channel membership, click onto the join button, select the 399 plan and grow your skills immensely.
cd diff, and you see var, only var is there. See? Only changes. So here you have it. Now what happens? I told you, just a second, clear the screen, go back. So guys, I told you, you can see the images and you can inspect the images also. Please try to understand that. This command is very powerful. And you see here, these are the layers. Now, these are the work directory, upper directory, merge directory. These are the mapping actually. Lower directory. This is the container overlay. Okay. And then overlay 5.1, 5.1, 5.1. So like this. Okay. So don't get lost. It's a SHA-256 algorithm. You have to understand how it works. Okay. So this is one. Now what I said also is, how many times this commit has happened. So if I see that image, 4 layers are there, that means 4 times the developer has committed it. So how do I see that? There is one command which is there, which is called a Docker history. So see here, this time, second time, third time, fourth time, and then here it got created one image db, which is a 0 byte. So here 72 MB, 1 MB, 800 plus bytes, 7 bytes, and here. So you can check this. 2 weeks ago, all this thing has happened in one day. How come? I'll teach you through Dockerfile. So guys, did you understand the first statement? Any confusion now? Any confusion now in this statement? Guys, are you there?
Yeah, Rajesh. So during container creation, the union mount happens, right?
Union mounts will happen. So now I'll come back one by one. So guys,
Okay.
these 2 points I have proven. So if you have any doubts on these 2 points, please tell me. Now let me show you what happens when you create a container. So union mount merger will happen all the layers and create a new layer which will be writable. Okay, so understand that. So can we do that? So let me create one container from that. So here I'll close this unnecessary. No. Oh shit, I closed the right one. Okay, just a second. Send crash sudo -s var lib docker overlay 2. Now guys, this is the one. So now can I see that? Can I create one container? So right now I am creating container run -itd ubuntu. Okay, and creating container. So guys, I created one container and you see here, this layer got created. This is the initialization for the user. This is in a very less in size. This is a meta information, but this is the real one. 677 MB. So the guys, this layer got created. Now interesting thing, you want to see 985 which is got mounted to the container. So do the df-kh and you see that 98, this got mounted to the only one container which you have here. That means what has happened, all the 4 layers got merged together and it's become one layer now. See here, and this layer got mounted to the container. You see that it's a mount df-kh mounted to the process, one of the process the container. That's the reason you can see the df table of the host machine also, and it got container. That means whatever you have in the merge layer, you see inside a container. And I've been telling you, each container get one mount initialized. So guys, did you understand this statement? Guys, did you understand?
Yes.
Now I said also it is writable, right? So here writable. So if I write something in the container, where the file will go? So let me write something. So Docker execute which container? This container. What I want to do? Touch. And where? OPT. And what? Raju.txt. So I have written some files, but where it is going? You look at this here. Raju.txt. It should go to the 98F8. Just look at this 98F8. 98F8 is there merged. So basically, which is writable? Writable is this container. This is writable. So anything which you write inside a container, it will go to the writable layer, which is this one, which is this one. So this is also proven. Is that clear, guys?
So Rajesh, if you can go to that mount location on the host, and if you write it, it will be reflected in Docker.
Yes, of course. Yes.
All right.
Of course. So guys, are you getting my points? What I'm trying to say? Okay. This I will show you a little later because you need to have a 2 layers for it.
If we create one more container, so will it use the same image? It should, right?
Same image, but not same layer.
Okay, so merge layer will be different.
Let me show you here. Why to have a confusion? Go to the command docker run -itd. Look at this, and here, look at this one more. 4.4. Look at this here. DFF and KH. See that? So always when you create a container, one merge layer get created, and that's writable. I've been telling you.
Okay.
Guys, did you understand this?
Yep.
Okay, now I have to delete that, guys, because I don't want confusion too many, because you will get confused. So what I'm doing, I'm deleting that another one which I created just for the demo. So Docker, this one, stop, and Docker RM. I'll delete is gone. Permanent gone. Now you have only one table, df-kh. Okay, df-kh, and here this one. Only one layer. Okay. So now next question, I said the writable layer divided typically in the two part. I'm not talking about the work right now. Diff and merged. So here can we see that? Can we go inside that writable layer which is get mounted? So CD, see here, and here you have a diff and merged. So what I said, diff you will have only the added, changed and deleted. Can I go and check, do you have raju.txt or not? Here, raju.txt or not? And if I see under the OPT, I have raju.txt. Only raju.txt in that. But can I go and check in the merge layer, do you have everything or not? Every merge layer, everything of all the layers plus diff. Do you have it or not? Look at this. Everything you have it, and including the one which is from the diff. See here. What is a backhoe? Okay, sorry. Where I am? Okay, sorry, I made a mistake. I got to here and CD OPT, not root OPT. And here. Okay. So guys, this statement is also proven. So guys, did you understand this?
Hi, Rajesh, I have a question.
Yeah.
So you have mentioned that the merge layer will be get deleted when a container is stopping, right? So what will happen to the diff layer then? It will be persist?
Yeah, it will be there. No, that's your delta. That will not be deleted as long as you not deleting the content.
Okay, so that means the merge layer is creating from the image, right? So that's so it will be again when the container is starting, it will be or this why that this means only the merge layer will be recreated again once
Yes.
your container is starting.
Yes. See, I'll show you that. No, let me show you here.
You removed one container, right? So can we see the diff layer of that also? Or
No. Remove container. You cannot see the diff layer.
Okay. Only stopped container. It will be there.
See here. right now diff merge and work. What I will do, docker ps. See here, docker stop, and this container. I stop it, and you see here ls. See here. So basically, why they remove the merge layer? Because that merge layer is already is coming from the layer which you have a writable read only layer, and delta of the container already stored here. So what happens when you start the container one more time? They merge all the read only layer and then delta layer. So that way you get the complete data in one go. See here, you get the complete data. You see here ls merged and opt. See, you get the complete data because raju.txt was in a diff and remaining files were there in the read only layer of that particular image. Got this?
But Rajesh, this merged will not change, right? It will be static for any given image, right?
Merge will be
So,
created only
correct.
from the image layer and the diff directory of that container if it is exist. If
Okay,
the container is not exist, it will create a new merge layer.
correct. So, which is what I'm saying. Want it to be like static, always, like when you're starting, multiple times. This merge would be would remain the same for all the stops, right? Or will it change? Is what I'm asking.
No,
Or
sir,
is there a possibility?
it will change. No, I mean, it will change and it will not change. Depends on what changes you made it. For example, let's see. I started. Think about it. Simple way. Right now, the container is running. Okay. So container is running. You modify anything inside the container, it will go two places. One is a diff, one is a merge. When you stop this, it will delete here. Now the data delta is already here. So next time you start the container, all the read only layer plus diff delta will be merged together in the merge layer. Who will do
Okay.
that? Union mounts. So ultimately you will not lose the data as long as the container is there. But container is not there, you lose everything. Diff, merge, work, everything.
Okay.
Yes.
Rajesh, just one more question. The image, suppose we have pulled an image, okay, and we have created a container, okay. So, and the container is stopped. Can we pull the latest image from the repository? Maybe some changes is added in the repository. The latest image is pulled. So, will it recreate the same container, or it will be totally a different instance?
That is where we need to think something. Okay.
Okay.
Let's think something. Okay. Let's think.
Okay.
Okay. See that I have been telling you, image is just a way for us, not for Docker. Understand that. For Docker, UUID is important. For human, image name is important because we can collect the ID, name, but we cannot remember the IDs. Right? So what is happening? What you are saying is a good scenario, but think about it. Let's do that. There's a one layer today, two layer, and three layer. Then what happened? You created the name of the image is like EIMG, only same name. See, this image is for the human friendly. So when you select this image, that means you are selecting this layer. This layer has a parent of this and this. Understand that? When you call the child, automatically parent will be merged, union mount will merge all this layer. You have already known that. So now what is happening? Suddenly what you did, you created some changes from this and you added one more layer and then you name it the image with the same thing. So now you tell me what you will see inside a container because you name this, you replace the name of the same tag with this one this time. So now if you create a container from this one, what you see, you tell me, you decide.
Which will have that all the four layers will be
Yes,
merged.
you will have it. So that is why we should not name it just like image. That is the replacement of the tag. So what you should do, image v1, v2, v3, v4, v5, like that if you do, then it will be making sense. For example, Jenkins, if you go here, look at this, Docker Hub and Jenkins, and here go to that location and they have a multiple tagging system. I'll talk about tagging. but you have asked, so I'm responding it. So see here, multiple tags are there. See here, I have a latest. Always I've been using latest, but they have also 2.6T or and they have Alpine, and this is also. So the 4 image you have here. Anything happens by default it comes latest. Now if you, that's the reason you see here you need the Docker images tag is always latest, but you can get it on the tag also. Did you understand that now?
Okay.
And Rajesh, one more thing: when you create a container first time, the diff will be already there, the directory, or it will not be there unless and until you make some changes.
Which one?
The diff directory.
Diff directory by default will not be there as long I think I did not notice, to be honest, but the moment you change the file it has to be there, because that's the place where it will get the changes stored, def stored. So I think it might get created, but it hardly matters because it's there or not there, it will contain the delta.
Let's assume I have one image of Ubuntu. So after I made some I created a container and made changes on top of it, and let's say after 3 weeks I'm again pulling the Ubuntu, and that has some more images. So how would my container look like then? Will it have
Same answer I think I have given it. Understand that system Docker read the image ID. So when you create an image here, then you get the image ID which is depicting this layer. When you create a new ID replacing the older one or downloading the new ID, you get a new image ID. Image also has an ID. Understand that. So Docker images, see image ID. When you create a new ID with the same name, it will be different ID. So when you see that container, let me show you the container actually. You should check this. Okay, Docker inspect, and they will not connect Ubuntu, but they will connect to the ID. See here, somewhere you should check it out. I have to read it too much. See here, image. They are not saying Ubuntu, they are saying this one. Are you getting my points?
Yes.
So that way its uniqueness is identified. So yes, to answer your question blunt way, whatever container you created, this will be keep running. Whatever a container you will create with after 3 weeks, that will also be running, because this container has a 3 layers, and that container will have a few more additional layers, and it will supply.
Is it Shantish? Are you asking that if you create an image on Ubuntu, what if you upgrade the Ubuntu? Is that what you're asking?
Yeah. That's the same thing. I got the answer now.
Okay.
Okay, guys. So can we move on now?
Just one more question. If you're already an image and with suppose a version 1 image is there, we have a running containers on that image. Okay. So the same time, if you are again pulling the same latest image it will totally it will not affect anything on the running container as well as the image. Previously, image will be persist as it is, right?
No. That's what I've been telling you. I try to understand this. Name is for illusion. Is for us. The ID is important, and when Docker works, they talk to the ID. But for human being, we say name. So let's say what you did. You this time you created one image with the same name, Ubuntu, with a 3 layer. Next time what you did, you committed same image name but with a 4 layer. So image is the same name, but so you have an image right now, older image. You will create a three layers will be merged. We have a new image, 4 layers will be merged. Now the question is,
will the host machine having both the images in the final
yes, you will be having both the images, but what will happen? Let me show you the Docker images. Whenever you say whichever the last commit you make it, that image you will see here, that the image ID will be replaced. Name will be same, but image ID will be replaced. And the timing created by also size also will change, because last one you see here, because if you have used the same name, If you have tag it, then it is a different case. Both you will see that. Ubuntu v1, Ubuntu v1.1. For example, let me show you, rather than talking, let me show you Docker Hub Ubuntu. And if I go here, Ubuntu must be having also multiple tags. I downloaded 19.0. I know that latest is 19.0, but you must be having 16 also, 17 also, 18 also. So let's go and check it out here. See, these are the tags. See here, 1804. I want 1804, not a latest. Where is the latest, by the way? Here, this is the latest. Okay, you see here. I want 1804. So I want to download Docker full repo name is Ubuntu, and this time with a tag 1804, 1804. And see here, so few additional layer will be there, because most of the layer will be already there, but few new layer will get it. Now if you see here, Docker images, see, this is the latest and this is the older one. So now you decide you want to create from this or this. Are you getting my points, what I'm trying to say?
Yeah,
Now the question is why. Now the question is, say, why this they did not complain about those existing layer, because those layers were unique for the 1804. This is 1904, I guess, or something, 1900 or something.
So now if you are making just referring the name while creating the container, it will use the latest one.
Yeah.
So if you want to create a container for old one, during the container creation also we have to point the tag or image ID.
Yeah, right? Yeah, image ID like this.
Can I move the container from one image to another?
Yeah.
Is it allowed?
I created new one, but this time 1804. Okay.
Okay, clear.
Yeah. So there was one question. Sorry, I couldn't hear you properly.
No. There is an existing container. So can I move it to the new image ID? Is it allowed or not allowed?
No, that is the topic we have. No, you need to learn how to create images. That's the reason I'm teaching you all the anatomy of the images. I'll create a new images in some time.
Okay.
Okay, guys. So I think the things which I wanted to tell you about the image anatomy, I hope you have understood. Can I move further?
Yes.
Okay. Now the question is, important question is, how do we create image? That's the question, right? How do we create image? How to create image? So basically, it's not image actually. To be honest, it's a layer, commit layer. Okay, one which you have a delta layer, commit layer. Okay, so how to do that? So guys, there's a two-way, using existing container, okay, and using Dockerfile. Docker. Now this is a automated way for CI/CD. Most of automated way CI/CD. Okay. Now this is a existing container. Now, do you want to know a little bit of history? Let's trace it back. So guys, Jenkins, I want to trace it back. Okay. So remember, each image you create, there is a base image, you have to use it. Okay. Each image you have to create another base image, and the last base image is the root file system. So can we trace it, Jenkins? Let's check it. So Jenkins, I'm tracing it. Okay. And so here, typically automated way, we create an image using Dockerfile. So let's trace it, guys. This is a Docker Hub Jenkins. Okay. Now here we have Jenkins. Okay. Now if you want to really see that how this image has been developed, look at the Docker file. So I've been using latest to click on the Docker file of the latest. The rule states that if you are an official image provider, please store that entire code and Docker file at github.com. So I'm using that same one. And here, please read only this one. So actually what has happened, Jenkins has been developed using the base image of OpenJDK. Yeah. So what they did, they took this image, and on top of that they added a Jenkins, and they started offering all of it. But the question is, what is OpenJDK? I don't know. So let's try to get to. This is a different image, okay? So Docker Hub, open JDK, enter it. Where is that? 8-JDK. It's not there, so I have to read that. It's a Linux x64 bit, right? Yeah. Not this. Where is that? It's here, AMD64. Because JDK can be installed for any platform, right? So that's the problem. Now look out this tag. Where is that? Here it is. So this is the Docker file. Okay. So you see here, this image OpenJDK has been developed using this image. See how I'm tracing it. You will find fun actually doing this. That why I'm tracing, because I want to teach you how can you develop your own image. Planning is you can learn from this. How these people are planning. These are the official image actually. OpenJDK is official image. Jenkins is official image. This is official image. So how they are doing it, you should learn from them. See, bustard.sc and Docker file again. Look at this. For this image, they see here that the same image, but the tag is different. See, image name is same, repo name is same, but the tag is different. So I'll go to that. This is the tag, and here see Debian. So now I can get it. Now you started getting the idea. Actually, Debian is a root file system. Basically. Now I will go to Debian. Hub Debian. Look at this here. And guys, what was that tag? Buster, right? Buster. Here it is. Buster. Guys, whenever you see scratch, that's the end of the story. That means see that how this evolution of this Jenkins image has happened. Look at this. End of the story. Scratch means nothing. And then what they are adding? A root file system. I'll show you. Do you want to see the content? I hope I have it. Let me check in my download directory. I think see. See here. Have you seen this?
So Rajesh, if we are building a custom file system, let me say from scratch, we need to build it like from scratch, and let me say you want some changes in root, we have to follow this approach from the Docker files.
Yes, you should do that. You should do that. This is the root file system, and whatever you want. See, the Docker is a kind of fun. Whatever you want, you can add it in the matter of 2 minutes, not more than that. So this is the Debian. You see that how evolution has happened. See, from scratch they created Debian tagged with the buster. From the Debian, someone created deps, build pack deps. From the build pack deps, someone created OpenJDK, and then from OpenJDK they have a Jenkins. So Jenkins needed what? OpenJDK. OpenJDK based on Debian. In between they install some curl, SCM, Git, maybe some utility. So something like that. So you have to plan your evolution. For example, typically how you plan. I'll just give you idea. You have to develop your own ideas. For example, your product is like a X product, very innovative product, but you want to run in RHEL, CentOS, Debian, Ubuntu. So that means you will have a 4 base, 1, 2, 3, 4. On top of that, you will install JDK,
To get our channel membership, click onto the join button, select the 3D99 plan and grow your skills immensely.
Okay. And top of that, you install Tomcat. Now here, Tomcat. Now Tomcat. Okay. And then after that, X. It's like this. So this is the one image. This is the one image. This is one image. And this is one image. So now let's say today, last month we had a Tomcat 5. By the way, it's 8, right? Right now it's a 9, I guess. I think 9. Yeah. So let's say last time you had a Tomcat 8. Now you want to upgrade it. So till here you can use the same thing. And Tomcat, well, you will create one more image, Tomcat 9. And then link this. Base image will be for X will be Tomcat 9. So easy. Within 2 minutes you get the new images. No worry. And same image you can spread to the whole world. I mean whole team, not whole world. And then within a second they can run the application. No talking, no documentation, no discussion, no fighting, no communication issues. That is called DevOps, right? And now if you want to change, let's say this is Ubuntu 18. Now you want to change 19. Then again you create from the 19. Then again JDK for 19. Then Tomcat, whatever the version, and then so technological upgrade you will do not every day. You will do once in a 6 months. But this code will modify every day. So probably you have to build 10 times in a day this code. So this base will be the same. Are you getting my point? I mean, the image is wrong. I mean, image is very bad, but are you getting the idea for that?
Yeah.
So this is how you can plan it out. So now the question was remain same. How do we create images? So I said, I can create an image using existing container, or you can use from the Dockerfile. Dockerfile I showed you. I will deep dive into that, but not now. First, let's understand from the existing container. So my manager said, Rajesh, can you do one thing? Can you create one? Can you give me the base of Ubuntu behavior and install the Java, Git, and Apache 2 or something like that, and give that image to me? Because I want to run that container which has a Ubuntu base, Java, Apache 2, Git, and da da da. So I said, no problem. I'll give it to you in 2 minutes. How? Look at this. So what I am doing right now is Docker run hyphen. Look at my screen, guys. Docker run hyphen it, not a d, because I want to go inside it. Okay, and I'm inside a container. What I will do, apt get install git. Git is not there, no problem. I will update it. Update. Oh, sorry, bad command. Done. Can I install the git now? Yes. Y. Remember, I am pushing Y. Okay. Understand this. I'm inside a container, by the way. Understand that. Git is installed inside a container. Wonderful. Do you want to install Apache? Apache 2? Web server? So nowadays they are asking this, all this stuff. So you can fill this. Some entry during automation, they will prompt you. Apache also is done, guys. Which Apache 2? What else you want? Apache 2 done, Git done, what else? So something like that install. You copy some file, you download some wget curl, this, that, whatever you want to do that. And Control PQ. Sorry, I did not press. Now I have this one. This has a Git plus Apache. Can I verify? Exit. See, Git is there in the container. Git is not there in the host machine. You can enjoy. So see, such a powerful tool Git you have. I mean Docker you have. You want to install some tool, but why to install for the permanent basis? You just need for a few seconds. So why to waste time? Create a container from the perspective image, right image. Use it. Throw that. Stop the container and then delete that. Your laptop is clean. Python, Perl, Java 3, 4, 5, 6, 7, 8, 9, 10, 11, Perl, XYZ, Ruby, Scala, Maven, Git, this, that, whatever the image you want, it just download, run it, use it, and throw that. So handy, right? Don't you think so? Guys, are you getting my points?
Yes.
So now this container has this container has sorry this container has everything whatever my manager has asked for it. Now what I'll do, I'll create a new image. How? Committing the container. Remember, when I say commit, it's committing the diff layer of this container. Okay, diff layer, diff directory. So commit, but what? This has Ubuntu. Why you are committing? You have to give the reason, right? M for, it's like a git commit, guys. Same thing. So update, and what was that? I forgot actually. Git and Apache 2, and it has update also, right? Update. So yeah, who are you? My name is Rajesh Kumar. And which container you want to commit? I want to contain this container. What image you want to give it? By the way, this command, if you don't know, help command, I taught you so many times. Help command is the best way to learn. I learned from that one only, trust me. And here, Docker images. So guys, I got this image. Now size is little bit large. Okay, but I got an image. Now I will do one thing. I will clear all of the containers first. So I can show you the right demo. Stopping all this thing and stopping and removing all the containers, because I got images. I don't need to worry about that containers whatever is running. So now I have images which is here, Docker run itd, now Docker ps. Now this container should be having Apache 2 and Docker. Let's git. So let's check it out. See, enjoy. So now the question is, I got the image, whichever my manager asked for it. How much time it took? Hardly few seconds. If you know that what need to be done manually or whatever it is, then in image creation just a matter of few seconds, not more than that. So guys, did you understand that the method 1 to create image? That's the reason I said, if you understand how the image anatomy of the images, creation is not taking much time. Guys, did you understand this?
Yes.
Yeah.
Yes.
The question is, my manager asked for it. How do I share? That's the question, is how to share my image with my team or whatever it is. How can I share? So guys, there are so many ways to share. One of the ways, tarball. You can create a tarball and SAP to the tarball to somewhere else and he will take it from there. Or you can use hub.docker also. Typically we will not use for the team, but still I'm teaching you. And you will use Artifactory also, Nexus also, ECR also. So many ways you have it, right? ECR on AWS, okay? Google registry also, Azure registry also. Guys, so many ways are there. You decide what you want. Registry. So many ways, 20s of ways to set. But as of now, I'll just give you this perspective. Okay, so let's do that. So guys, creating a tarball, save output, where output what you want. The image name I'll keep it same one, tarball. Which image? This image. Creating a tarball, guys. I created tarball. You see here this image. If you really want to understand what each image will, you may have a content. Each file you want to understand the anatomy, meta information, SHA-256, everything you want to learn, untar it and go through each and every file and understand this more way, better way. You'll deep dive. Again, read about the SHA-256, how it works. Deep dive into the SHA-256. You'll love it. This topic is very interesting. By the way, that's not topic for us. Now, what I'm going to do, I'm going to stop all the containers. So, because I'll not be able to remove that image. So, stopping the container, removing the container, and Docker RMI, this one. Deleted that image, guys. Now, you see that the image is not there anymore. So can I load this? Docker load from what? Input. Which input? Up. You have to do as another guy. That's the reason I deleted. So now other guy also got the images. Now do whatever you want with this. Sharing is so easy right now. So this is the tarball. This is the way you can share the images. Guys, did you get it? This one?
Yep.
Now, how do we share through dockerhub.com? Guys, you have to register it. Hub.docker.com is just like a github.com. You can register it. It's a free account. Anyone can do that. You can create unlimited public repository. You can have one private repository. So I have accounts, so I don't have to register it. You have to register it, and you have to share a URL with me. That's the assignment. Because if you do not share a URL with me, how do I come to know whether you have done it or not? So you have to share with me after some time during the lab time. Okay. So I am logging it. Anyone can register with the email ID and stuff like that. So the site is little slow. My ID is Demo Schools. So guys, here I have created a lot of it. I'll create one more. I should have cleaned up actually. Lots of unnecessary repository I created. Okay, so what is the day today? It's August and 13, right? This is the repository I'm creating, and you can feed public, private, description, this, that, and all these things. You can do that. Guys, are you able to hear me? Hello? Hello? Hello?
Yes, Rajesh. we can hear.
You are back.
Yes, sorry. Hello? Can you hear me?
Yes.
Okay, actually I got the internet disconnected, so I had to connect the backup internet. Thankfully, that backup internet is okay today. Okay, so guys, can you see my screen here?
Yes.
Okay, so Augustine 13 public repository I'm going to create. So remember, my public repository, anyone can access it, anyone in the whole world. What is the name of the repository? DevOps Schools / and Augustine 13, August 13. Okay, so here I'm going to, can you see my putty session?
Yes.
Okay. I think I lost this connection. I have to use this. CentOS. Sudo -s. So guys, what I was doing actually, yeah. So I have created that one repository which is here. So I'm going to log into the hub.docker.com. How can you log in? So Docker images. You see here, I have the images. Docker login. Okay, login. I have a ID DevOps schools and password I don't know. And you see login succeeded. Now what I'm going to do is I'm going to push that image to the repository, but there's a, see, let me push it and let me show you the error, because many of you will ask me I'm not able to push it. So push, I'm pushing this. So now here you are pushing, the repository name is here. Remember, sir, this is the repository name. Look at the column. So you are saying access denied. So you are not having this repository. What is the repository name? Your repository name is DevOps Schools / August 13. Uses a 13. So that's your repository name. So repository name must match. Now the question is, how do I match? So I don't want to create a new images and matching that. What I'm going to do is I'm going to tag it, which is the existing image. Tag to this to the one. Okay, and tag it. Guys, you see here, is image is just for human. Understand that image name. See that this name and this name both are tagging the same image ID. So now if I push, I'll push this one. So Docker matching, repository name is matching. Push what? This, and it will take a few seconds. Depends on the internet connection speed around. Okay, it's 250 MB, right? So we are pushing this. So now I could share through registry to the whole world. By the way, this same command will work with Artifactory also, Nexus also, ECR also, and any registry you use it. Login, push, tag, all these things will remain same. And guys, I almost pushed it. Confirmation is pending. And now anyone in the whole world, those who want Ubuntu plus Apache 2 plus Git plus whatever it is, he will go and pull my image from here. This is the my view, public view. You can go ahead and pull this. Did you understand that, guys? Now updated few seconds. Tags with latest. Guys, did you understand this?
Yeah.
So guys, this is the way you can share the image using registry. So using registry. And here the code I'm sharing with you, which is here. Okay, so I think this is the good amount of things we have had it. I'll let you allow do some lab also, and then last topic, which is automated. That's also simple, not very difficult, but I'll teach. Okay.
Please enroll our general membership for $399 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.